and welcome to the Quantitative Analysis Institute. Today I'm going to talk about dates. In R, dates can be fairly tricky to work with. So first, I made a little data set called birthday data, and we're going to read that in so that we can understand how these dates work. So if we look at this data set, you can see that there's a subject number, the day of birth, the month of birth, and the year of birth. Now if we want to create another column that has the dates in a format that we're actually able to work with, we have to use something called the paste function. So we can use the paste function, and you can look up its help page if you are still confused. You enter the different columns that you want to paste together. So you can put in the month of birth, day of birth, year of birth. So we know that these are all within the dataset small. So when we run this, it will create a combined birthday. So if we look at the combined vector, we can now see that instead of it saying 12 April 1994 in all different columns, it now says April 12, 1994. So now an easy way to add a column to a dataset is by writing the name of the dataset in these square brackets, writing the name of the column that you want it to be called, and then using our little arrow and putting in the vector that you want to be as values for that column. So it will add combined to our data set, and now we can look at our data set and you can see that it has been added. So we want to create a numerical birthday so that we can actually do things like figure out how old somebody is. So there's this function called as.date, and you place in a vector as the first argument, and then the format of the date in the second argument. So what you have for the format is you have all of these little codes. So for example, $B means the full name of the month, and $d means the day of the month in a number, and Y means a 4-digit year. So I picked these because in our full birthday column, we have $B, then a space, then $d because we have the day, then a space, and then a full 4-digit year. So if I run this, I can now look at our birthday number vector. So now you can see that R has converted our full birthday into something that it can understand. So it has it in the form year, month, day. So 1994, 04, 12. So let's take a little digression and look at the different formats that you might have your dates in and what you can do when you're reading them in. So there's only one choice for day, and that is $d for the number of the day in the month. For month, we have three different options. We have $M, which is lowercase, which is the number month. We have $b, which is the three-letter abbreviation, like OCT or JUL for July. We have $B, which is the full name for the month. Year also has two options, $y, which is only a 2-digit year, such as 94, and $Y, which is a 4-digit year, such as 1994. So let's look at one date in several different formats and how you would have to tell R what it is so you get the same output every time. So let's look at the date October 15th, 2014. So if we have it in the format Oct 1514, we tell R that we have the three-letter abbreviation, the day, and a 2-digit year. So if we run it, we can see we have 2014-10-15. If we have it in words, October 15th, 2014, we can say that we have the full month, then we have a space, then we have the day, then we have the letters TH and a comma, and another space, and then we have a 4-digit year. We can see that this also spits out the same date. If it has slashes, we can say month/day/year. If we're in Europe, we could say day/month/year. As you can see, these are all spitting out the exact same output. You could also have something like periods separating the month and the day and the year. No problem. Just as long as you tell it in the formatting area. One special note for both months and days that are single digits that you need to know is that if you have the date as 02/01/2011 without any demarcation between the month, the day, and the year, you have to have the zeros prior. So for this, it knows that this is 2011, February 1st. But here, if we have 2/1/2011, R doesn't understand what to do with this, so it displays NA. However, if you provide a demarcation between the day and the month and the year, such as 2.1.2011, R has no problem. Another thing that's interesting to note is that R internally keeps track of dates as days since January 1st, 1970, with negative numbers for dates that occurred prior to January 1st, 1970. So you can convert the output of this to the internal form that R is dealing with if you'd like to look at it. So we can say as.numeric, and then we can look at our date, which I'm going to put in February 1st, 1970. So this gives us 31. This makes sense because we know that January has 31 days. There are several applications for the as.numeric function that you might want to look at how many days there have been since a certain day, but we're not going to go into those right now. So back to my little birthday data set. We're going to add our birthday number to our data set. So we can look at it again, and we can see that we have in this nice format that we've been talking about. We can also use something called sys.date. Sys.date. And this does not take anything in the parentheses, and it tells you what the date is today in our year, month, day format that we've been using. Okay, so let's just call that today so we can remember that. We don't have to keep typing sys.date. There's a package called lubridate that makes it quite easy to manipulate dates. The basic stuff that's in R already is not super easy to manipulate dates with, so I like using this package. So once you've installed it, you can load it into your library. And they have a function called wday, which figures out what the day of the week it is for you. So it takes two arguments, the date and the label. And if you have the label being true, it will tell you sun, mon, tues, wed. If you don't have the label, it'll tell you 01, 02, 03, with 01 being Sunday, 02 being Monday, etc. So we can see what day of the week it is today. So now I can see that R is telling me that it is Saturday today, which is true. So that's good. So we could see what day of the week people were born on. We could look at our weekday of birth. Weekday of birth. So we can see that people were born on Tuesday or Wednesday or Sunday. There are a lot of people born on Tuesday in this little data set that I made up. So another function that lubridate has that's quite useful is that you can make an interval between two dates. So this function is called new_interval, and you put the earlier date and then the later date. So if we run this, you're not going to want to look at the interval very much because it just tells you how it's calculating the difference between those days. So now to get something that we can actually understand, we want to convert the interval into a period. So this would be the person's age in years, months, days, hours, minutes, and seconds if we put it into that degree of precision. So we can call this whole age, and it'll warn you that there's a negative sign, because if you place these numbers in backwards for the interval, you would get that people are negative years old. Even if you do that, it doesn't mean much. It doesn't matter. So we can look at people's ages. So we can see that this person is 21 years, 2 months, 15 days, and then these 0 hours, 0 minutes, 0 seconds. We didn't put the birthdays in for that precision, so they don't mean anything. I'm not sure why some of them say 1 hour and some of them say 0 hours, but that's just how it is. Since we saved this as an object, we can now obtain the years from it. And so we can look at age years. So we can see that people are 21 or 20, 18, etc. So now we can use our same format and add people's ages to our data frame. Now if we look at small once again, we can see that this person's 21, this person's 19. So now we can look at the difference between the way that birthdays and ages are stored by making a plot. So let's plot this. So here you can see that even though these people were born at different times in 1994, they are all 21. You can also see that because we are in June, which is the middle of the year, the people who were born in the second half of 1995 and the people who were born in the first half of 1996 are all 19 years old. So what you can see is that when you calculate the age using this lubridate package, creating an interval, converting it to a period, and then selecting the year attribute, you only get a finite number of options. For example, somebody could be 21 or 20 or 19. They could not be 20.7. But if you're looking at somebody's calendar birthday, you can see that there's a different spread. It can differentiate between January 1st and February 2nd, for example.